This is how to do inverse trig functions. Here are the trig functions sine, cosine, and tangent. Their inverses are written as inverse sine, inverse cosine, and inverse tangent. This is a graph of sine and inverse sine, and we can show their inverses by drawing a line down the center. This is the line y equals x. We know that graphs are inverses if they reflect over the line y equals x.
The rule of trig functions states that if the sine of theta equals x, then the inverse sine of x will equal theta. This applies to all trig functions. The inverse sine of theta will cancel out to equal just theta. To have the inverse of something, you have to have the other variable. So in this case, you're solving for theta. To cancel out the sine, you multiply by inverse sine. You multiply it on both sides. The inverse sine and the sine cancel out. This becomes the inverse sine of x equals theta.
In our first example, we have inverse sine of 1/2 equals theta, and we're trying to solve for theta. Multiply by sine, which goes into both sides of the equation and cancels out the inverse. This leaves us with sine of theta equals 1/2. We can look at the unit circle to find out when sine equals 1/2. Since 1/2 is positive, we only look for answers in the first quadrant where both coordinates are positive. Since sine is the y-coordinate, the only solution in the first quadrant is this 1/2, which is pi 6. Sine of theta equals 1/2 at pi 6.
Now we will look at the properties of inverse trig functions.
The domain measures the graph from left to right, and the range measures it from bottom to top. If we look at the red graph of inverse sine of x, we can see that the range, or the domain, is from here to here, from -1 to +1. The range is from here to here, from -pi/2 to pi/2. The blue cosine graph has a domain from here to here, also -1 to +1, and a range from here to here, 0 to pi. The domain of the black graph, inverse tangent, goes from -infinity to +infinity and has a domain of all real numbers. The graph is bounded at this line above and this line below, which are +pi/2 and -pi/2. So the range is also -pi/2 to +pi/2.
You can also see the inverse functions written as the arc of a function. For example, instead of the inverse of sine, it's written arc sine. You will also see this applied to the other trig functions. It is also common to see the inverse sine of theta. It is also common to say the arc sine of theta instead of the inverse sine of theta, and arc cosine and arc tangent instead of the inverse as well.